Have you ever considered that the very technology designed to save lives could actually endanger them? Today, we're diving into a critical issue: I's alarming potential to misinterpret genomic data when diagnosing rare diseases. This is a risk you cannot afford to ignore. Picture this: after years of battling unexplained symptoms, you turn to advanced eye software for answers. It seems like a beacon of hope, but what if this eye misses a crucial detail? We often trust machines blindly, but lurking beneath their polished surfaces are dangerous assumptions. Many people are unaware that I can misread genomic data, leading to catastrophic misdiagnoses. Imagine being told you have one condition, only to discover weeks later that it's entirely wrong. Now, think about finally receiving a diagnosis after a long wait. The relief is palpable. But what if that diagnosis stemmed from an eye error? A single misinterpretation of a gene could lead to the wrong treatment, putting your health and future at serious risk. Consider the story of a mother whose child has a rare condition. After endless tests, eye identifies a genetic disorder, filling her with hope. But later she learns it was a misread. The real issue was a rare mutation that the technology completely overlooked. This isn't just a statistic, it's a heartbreaking reality for countless families. Each misdiagnosis sends shockwaves through lives, altering decisions and futures. As we advance, the potential for error looms larger, hidden within complex algorithms. And there's more: the design of eye systems can lead to biased outcomes. The data used to train these systems often lacks diversity, amplifying mistakes and misreads. This isn't merely a tech issue, it's about real people affected every day. So, what can we do in a world increasingly reliant on eye? Awareness is vital. Engage with your healthcare providers. Ask questions. Don't let the allure of technology overshadow the unique nuances of your genetic story. As we wrap up, reflect on this: in our quest for answers, are we neglecting the human aspect? Sometimes the most valuable insights come not from machines, but from the stories we share. Before you leave, remember: the next time you hear about a groundbreaking eye tool, think twice. Behind every innovation lies the potential for dangerous misreads. Stay informed, stay vigilant, and know your health deserves scrutiny. Have you ever wondered why some rare diseases go undiagnosed despite our advanced technology? It can feel like we're searching in the dark for answers. The unsettling truth is that I might be misinterpreting genomic data, contributing to this issue. Imagine a family desperate for answers after years of uncertainty. Doctors run tests, but the results are inconclusive. They turn to eye hoping for a breakthrough. But what if that eye is missing critical signals hidden in the genome, or focusing on the wrong aspects entirely? In our data-driven world, we rely on algorithms for guidance. They promise speed and efficiency, yet there's a concerning gap between what they can process and what they truly understand. This gap can lead to misinterpretations that affect lives in unimaginable ways. Consider a child with unexplained symptoms. Doctors are puzzled and the family feels hopeless. They turn to genomic testing, believing I will uncover the missing pieces. But what if that technology overlooks rare variants that hold the key to their diagnosis? As we delve deeper, the complexities of genomic data become clearer. Rare genetic variants often go unnoticed by eye models, leading to incorrect conclusions. These misinterpretations can mislead families, leaving the real answers hidden in the data. Frustrating twist of fate. Now, here's where it gets even more complicated. The algorithms we trust are trained on data sets that may not represent all populations. This means certain genetic markers could be completely overlooked, especially in rare diseases affecting minority groups. The implications are staggering. Imagine being part of a community that feels invisible. It's a haunting reality for many. As we advocate for more personalized medicine, how can we ensure everyone is acknowledged? The stakes are high. Misdiagnosis can lead to ineffective treatments, trapping families in a cycle of hope and despair. The very tools designed to help us might actually be leading us astray. But there is hope. Researchers are exploring ways to enhance eyes' ability to interpret complex genomic signals, which could lead to more accurate diagnostics and better outcomes. As we navigate this challenging landscape, we must remember the human stories behind the data. Every number represents a life. The future of genomic medicine depends on bridging the gap between eye and the intricate reality of our genomes. So the next time you hear about the power of eye in healthcare, and as we move forward, let's ensure that no one is left in the dark. If you found value in this journey, please share it. Awareness is our first step toward change. What if I told you that the latest eye technology might be misleading patients about rare diseases? It's a concerning thought, right? These algorithms could create a dangerous illusion that impacts lives. The reality is that eye's role in interpreting genomic data for rare diseases is more complex than you might think. As we explore this topic, you'll uncover something many people overlook. Imagine receiving a diagnosis from advanced eye analysis. You feel a sense of relief thinking you finally have answers. But here's the catch: that analysis might be flawed. These algorithms are often trained on datasets that overlook rare conditions. So when they encounter something unusual, they can easily misinterpret it. Picture a parent desperately seeking answers for their child's unexplained symptoms. They turn to doctors who rely on eye systems promising accuracy. But what if those systems are based on outdated information? It's unsettling, isn't it? Now let's consider the real-life consequences. Imagine Simone's entire treatment plan hanging on a genomic test result. Decisions based on incorrect eye interpretations could lead to unnecessary treatments, or even worse, missed opportunities for effective care. Why aren't we discussing this more? The risk of misinterpretation isn't just a technical issue, it's a ticking time bomb for countless families. As these eye tools become more prevalent, the stakes are only getting higher. There's also pressure from some organizations to prioritize speed over accuracy in diagnoses. In this rush, are we sacrificing the quality of care? The drive for innovation might overshadow the need for precision. Imagine being left in the dark, even with access to advanced technology. You trust the system, but it's letting you down. What would you do next? Before we explore potential solutions, let's acknowledge the tension here. Families are caught between hope and despair. The answer isn't straightforward.